what a trip with the music of Vangelis. So after seeing the movie, who would like to be somewhere in your life to be an astronaut now? Yes. I like to welcome on stage, the director of this movie. It's the first movie he made, and he happens to be also the only living Dutch astronaut. Please welcome Mr. André Kuipers.
Dankjewel. Fantastisch.
Welcome, André. From astronaut to movie director. Beyond O2 Earth.
Well, I started as a medical doctor. So I came from a medical world. Then I came into aviation and space, a very technical world. And now I'm a director of a movie and theater shows, etc. And it's all very interesting worlds. All teamwork. That's a very important one. It's all teamwork.
That's important. And beyond, when did you arrive at the idea of making this movie, and what do you want to bring to the audience with your film?
I like to present things. Also, before I became an astronaut, I like to talk about medical aspects of space flight, about accidents in space, in the planetarium, and in Amsterdam. We have a little problem with the sound, but my voice is strong enough. So I like to share knowledge, to make people aware of the beauty of, in this case, space. So when I became an astronaut, this was part of the job as well. An astronaut is paid by tax money. So one of the tasks is to show the people what we actually do with the money of the people. So it's a task. Some astronauts like it, others don't. I like to give the presentations to show people how beautiful it is. So I gave a lot of presentations already, and I used all kind of material from my space flight, from other space flights, and then I like also science fiction and space documentaries myself to look at it. Then there was the idea to make a festival, more or less, of space movies or documentaries. And I thought, that's a nice idea. A whole weekend, just space movies. It would be nice. And then the people who organized it said, well, it would be good if there is something original in there. Something with your images and what kind of music you heard. I thought, that's a nice idea. Well, the whole film festival is still, maybe in the future. But the film started to live its own life. It became a film on itself.
And you already mentioned the music, because Vangelis music, a little bit of Armin van Buuren, right? And
because I thought, okay, I want to bring the people along. That's what I try to do with all my presentations, bring people along, as if you're part of the crew, if you're in there. So I thought, okay, I want to show what I saw, but also what I heard, or the sound, the music I had. Because one of the things you do in space is reliving your own dream. I liked space flight as a small child already. When I was 12, it all started, and it was always associated with music. The music on the radio, but very special music, soundtracks of movies. So I created my own soundtrack of my own life, more or less. And I thought, okay, this is what I really listened to in space. And so you have your free time, and you go to the window, and then you put the music on that you heard already as a kid, as a teenager, to come back in your own dream. That's what I was trying to do. Because normally it's hard work, space flight. It's not a holiday. You're constantly working. You have to be careful, and you have to be attentive. So
let's get into that a bit, because living in a spaceship, because you did 2 trips, and the first one was some 11 days, and then the second one was 193 days. Correct. So that's longer time. And can you share a bit, like living there, being there?
Yeah. Well, it's like spaceflight is like any other activity that you dream of to do. Maybe people dream of tropical islands, beautiful white beaches, etc. Beautiful. But once you're there, it's very hot. You're bitten by sand fleas. You're thirsty. So reality is always a bit different than the dream. And same for spaceflight. if you come into space, you're sick. Lots of astronauts are space sick, some seasickness. So you have a fluid shift, so you get a swollen face, and you have back pain because you get a bit taller in space. So in the first days in space, you think, "Oh, why did I start? I feel terrible." But luckily, your body adapts, and after a while, I feel very comfortable, like a fish in the water. So, but it takes some time, and you have to work very hard in space. There's a lot of time, energy, money put in what you do up there. So you realize that astronauts are pretty responsible people because they know what's behind it. And you don't want to make big mistakes that you ruin an experiment or something worse even. So you're very concentrated. And sometimes you cannot be on all the time. So sometimes you have some relaxing time.
Yeah, and that's when you listen to
And
the
that's where you go to a window and then you realize, oh, wait a minute. I'm not in a normal lab. I'm in space and there's the Earth and I float here. And then you put the music on and then, wow, you're in your own dream. That's fantastic. But
And
it's...
you were in contact with the composer van Jealous
Yes.
as well, right?
Yes, actually, I invited him already for my first launch, but then he was making the soundtrack of the film Alexander, so he couldn't come at that moment. But in my second flight, I got the opportunity to make some private calls, more or less. So on the Sundays, there's less experiments, so you have some more bandwidth, so we could have a video connection with the home front. And now and then, they allowed us to talk with somebody special that you want. A Canadian colleague talked with an ice hockey player, and my American colleague had John Mayer. So I waved to John Mayer when he passed by on the screen of her laptop, this kind of stuff. And I thought, oh, I like to speak to Van Jealous. And so Isa arranged that for me together with NASA, and that was fantastic. So he was in London playing piano.
Yes.
And I could show him the Earth through the window. While he was playing for me. So that was beautiful. For both sides, it was very special.
And you were looking out of the window at that vulnerable Earth.
So that was fantastic. And he always loved space. Huh? I mean, I now have all his albums, and I thought he loved space. I mean, he made music for the Methodia, that was for a Mars mission for NASA, for Rosetta, the famous mission to the comet, for Juno, but also in his first albums, there's a lot of space in there. In Pulsar, what you heard later on, as well as a version of Armin, but also Albedo 039, which is the reflection of the Earth, and so I put that also in the movie. So he was very much related with spaceflight, so he loved it. And actually, when he heard that I was going to make this movie, he said, "Well, I'll make the whole soundtrack." And then I showed him that I took 40 tracks, more or less 40 tracks of his whole work, or all his work, his whole oeuvre, and he loved it to give this the new use of his old works. And so I remember the day he called me. I was in the car on my way to Paris, actually, to him. And then he said, "You made my day." He loved it. All these old tracks that we were reusing for this, and not the obvious ones, because as soon as you hear Chariots of Fire or 1492, the main theme, then you have other association.
Yeah, with that.
You think of the movie.
Yeah, I see running people.
Yes.
And,
so then I took tracks of these albums that they're not so common.
Yeah, less known.
Yeah, less known, and so I wanted to make an own soundtrack with 40 of his tracks. It was a very nice job, but very complex, because I had constantly had to find, okay, what kind of feeling do I get from this music, and where does this belong? Is it something explosive for a launch, or something serene? So it was very interesting to listen to all this music, and then this is teamwork as well, because then you have to sit with the editors and constantly moving pieces of film and pieces of music and make it all fit. It was a very nice exercise, actually. Yeah.
Behind you, we see this image of the Earth, and it's striking. We see always the dark side of the Earth, and we know these stories from you and other astronauts that if you look back at that Earth, you have this overview effect, and you see that it's this vulnerable entity that we're all on. Here we see all these lights emerging, basically cities that you can see from space. And 1,000 years ago, that was pitch black. There was nothing. So the Earth is also changing. And how from space, when you look at that Earth, what kind of sense do you get, not only on the beauty of biology and ecology that's there on Earth, but also the human presence and all the technology?
Yeah, you can clearly see that there are humans on this planet. The day side, there's actually 3 sides in that sense, that the day side's beautiful. You have the beautiful turquoise waters of the Bahamas, these red deserts in Australia, and ochre high plateau of Tibet with green lakes and beautiful colors. Then the sun goes low and you get the reflection, the sun glint. That's beautiful. You saw it also when you saw Holland, for example. When you saw that's beautiful to see all this, a totally different view. And then you get it to the night side. And so we have 16 times per day sunset, 16 times per day sunrise. So, and that's beautiful because the sun goes through these dense layers of the atmosphere, then you get beautiful colors. So for a few seconds, 5-6 seconds, you have a golden space station. And that's fantastic.
16 times.
16 times per day. If you miss it, no problem. 45 minutes later, you have it again. You can see it again.
And the biorhythm, how is that?
Yeah, we use Greenwich Mean Time because you cannot work with light or dark. That's impossible. So we use Greenwich Mean Time on board. But at night, I felt that I was in the science fiction books of my youth. It feels like you're flying to another planet, an exoplanet somewhere with intelligent life, and you see all these lights. It felt really like a science fiction movie. But it's very double. You see, it's beautiful. All these lights, fishing boats. You see off-gassing of oil rigs. You see the city lights and the roads, and it's beautiful. It's like black velvet with golden embroidery on it. Very nice. But you also realize, whoa, there's a lot of people. You see lights everywhere. Even in the Sahara, you see lights everywhere. And only maybe on the ice field of Greenland or something it's black, but in the oceans you see lights.
People everywhere, activity everywhere.
A lot. And that's it. Then it looks also a bit like a plague. You know, we're just growing and growing and growing. If you realize that we grow with 200,000 people every day, that's Eindhoven, eh?
Every day.
A city like Eindhoven, every day extra.
Yeah.
They all want water, they all want energy, they all want transport. So it's a double feeling. It's beautiful. On the other hand, you think, "Ooh, there's a lot of people here." Yeah, and the planet is not growing bigger, eh? So
no, and I think recently scientists also calculated the weight of the technosphere. So if you put all the technology and that's your smartphone, this microphone, but also the building, these are all inventions made by humans. That is already heavier than the weight of all life on the planet, all plants, animals, humans together. So and this is happening in our lifetime. Yeah. So there's something. What should we do? I don't expect you to have all the answers, but what should we do about it, André?
Well, we have to be smart. We are smart. By the way, we are very intelligent. We can find a lot of solutions in food technology, and now with quantum and AI, things will go very fast, etc. But to be intelligent is something else than being wise. Yeah. And we have to be careful. If you see all the fishing boats on the planet, it's beautiful, all these lights, but you also realize, this is not endless. If you look at an ocean, you think, fish enough. If you walk in the Amazon, trees enough. But from space, you see how limited it is. Yeah. And that's something we have to try to realize, that Earth is a spaceship. Eh? We started to talk about that in the Apollo era, that we are all astronauts on a spaceship with limited resources, which it is. And so if you're smart with your resources, you make sure that the Earth has recovery time for the fish, for the forests, etc. So we can keep on using it. Yeah. If you are a good farmer, you don't empty your land because you want to harvest next year as well. So you have to be careful with it. And we should do that with the Earth as well. That's a bit of a problem. We think it's all endless, which is not. And from space, we realize that we can measure it much better than with the human eye. All the things that you see is limited. I mean, our eye we saw it in the presentation actually earlier today. It's very limited what we see with the naked eye. With satellites, you can see in all these wavelengths. And then you get a good picture of what's happening on the planet. And we are a bit like a plague, like a locust. Eat until everything is finished. Yeah. So normally it doesn't end good with the plague.
No, and then because I think if you describe us as humans as a plague, and then we say now we have to move out to other planets and then be a plague there, that's not something that I find desirable. So let's maybe first show we can live in a harmonic way on Earth with the life that's already there and the human presence before we move to another planet.
Well, I don't think it bites each other. I don't think this is not that it would not be compatible.
Mhm.
I think we should use space, what we already do, to make life better here as well. Of course, we cannot solve it by saying, okay, it's full here, we emptied it here, we
No.
finished it, we
Yeah, let's
just
not
go
do
to
that.
Mars. No, we can forget that. I mean, you would have to launch 200,000 people every day to Mars. And
Yeah, the
there's not-
city of Eindhoven.
and there's nothing there.
No.
Okay,
Okay,
this is
so
the problem.
that's-
So that's not a solution.
Yeah.
So, but we can use space very well.
Mhm.
Now, at the moment, is to measure. We measure all these things. Then we know that there is a hole in the ozone layer. We know that there is deforestation. We can measure that from space. The ice is melting. So we have all the proof. We have all the scientific data for that. Now, in the future, this is in the future, I think we can use space. We can use space for resources.
Mhm.
We can use space for forms of energy. So I think this is a good thing. And I'm not afraid that we destroy the moon, for example. We cannot destroy life there. There's other discussions, of course, that the moon is something spiritual as well.
Mhm.
And we should not, but we already destroyed it. There's all kind of cars already there.
Yeah, I know.
So-
we left the car
Yes.
on the moon.
Right, several. Yeah. So if
Yeah,
you
yeah.
Want, if you want a moon buggy, you can get it there.
Yeah, it's
So
still
it's
there.
still
Someone
there.
went there, drove a car, just left.
So
Yeah.
in the future, you might have mining on the moon, mining asteroids.
Yeah.
I hope in the far future, maybe this is at the moment is pretty utopic, but that we use space to leave Earth alone. So that we can use space for resources, for energy, for minerals, whatever, and that we make Earth a beautiful park where we live together with
Ah.
plants and animals. That is my
That's a beautiful
utopic vision, and
Yeah.
not in my lifetime, but that would be the best way. So I see the far future that the humans, whatever it is, humans, maybe it's a mix, hybrid with new technologies. That's what I will see. So we take the best from all kind of from technology, from biology.
Humans will change.
Of course,
Yeah.
it's constant evolution, and in the future
Yeah.
it will be different.
Yeah.
And that we will spread out. It's now impossible to spread out. I mean, there will be some astronauts hopping around on Mars, but that's it. You
Yeah,
know?
as a
The other ones are too hot, too poisonous, too far. Exoplanets takes us at least 10,000 years with the fastest spacecraft we have now, but technology doesn't stop. In the far future, there will be technologies we can not even think of now. So that is, in the far future, we will spread out.
and
for
far
sure.
future, then I should think like 100,000, maybe
Yes.
even 100,000 or
Yes.
million years.
Yes,
Yeah,
I mean, it's
okay,
not,
yeah.
million years
It's
is nothing.
refreshing because typically the average politician thinks like 4 years.
Yeah.
And here, well,
if they're lucky, if they're lucky.
you visited our time machine, which is there on,
Yeah.
on the ring that brings you also
Yeah.
in the far future. I remember when André came out, the first thing he said was confronterend.
Yeah.
Because then you made this trip beyond the end of the solar system, and because the
yes.
sun has a lifespan as well.
Absolutely, but it's about 2 billion years before it starts. So
Yeah, we have some time. Not to worry, people. Maybe this is a good moment also to go to this part of the session that I'm sure some of you have been waiting for, which is the opportunity to ask a question to the movie director and astronaut André Kuipers. And if you are not comfortable with asking your question in English, no problem. We will try to translate it for the people that do not speak Dutch. And there is a microphone. So there you are. Raise your hand if you have the first question. For André, there's here one. Yeah, there we go. There's a young one. You are next. You're next. I've seen you. You're first.
Well, good evening. Thanks very much for a lovely movie. I'd like to know, when you see the space station, do you know every nook and cranny already, or do you actually learn when you arrive?
Well, that would be bad. But I don't know everything, of course. And that's the thing you learn in the first place. because I thought I cannot remember all this. You get all the electrical system and the temperature control system and all the computers and all. So the trick is that you know how to find the problem, that you can navigate in the computer system, that you can read procedures, assuming that they're written correctly. This is not always the case, but if you can understand procedures, you know how to use your tools, and you can find your problem in the computer. Where is the short circuit or what's wrong? Then you can actually solve a lot. So you get mostly training on how to do your job. You cannot remember everything by heart. This is impossible. And we have several levels of expertise. You have the user level. So I was a user in the Russian segment. So I know how to get my power, how to make food, how to use the toilet, where the fire extinguisher is, etc. So like a passenger in a plane, for example. You know how your belt works, where the emergency exit is, if you pay attention to the stewardess, but okay. So that's that level. Then you have the operator level. I was an operator for the American segment and for the Soyuz, so I knew how to fly the thing. I knew how to use all the equipment, etc. And then there's a third level, it's the specialist level. I was a specialist for the European part and for the Japanese part. So if something breaks down, I was the first one to fix that. So there's all these levels. You cannot know everything. Nobody knows everything. And don't forget, the astronauts are just the hands and the eyes of the people on the ground. It's really teamwork. So you constantly communicate. You constantly hear people talking with Soup in Moscow, with Tsukuba in Japan, with Huntsville, etc. You are just doing what the ground wants you to do. You are you're doing the job with the people on the ground. So if there is something wrong, they can send up video clips and all these things. So you learn a lot on the job in that sense. But the basic things you learn on the ground, especially emergencies. 80% of what I learned, I never used. 80% is problem solving. A short circuit, or the big ones, a fire or a leak. It's like a pilot in an airliner. Most of his, probably his whole career, nothing serious happens. Flying is the most safe form of transport. But in a simulator, everything goes wrong all the time. Same for us. We mostly learn how to solve problems that hopefully never happen.
I'm sure that answers your question. And here's the second question. Yeah. This young man was already raising his hand.
Hoe voelde je toen je net opgestegen was en hoe voelde je toen je gewichtloos was?
The question. So how do I feel? How did I feel during launch and when you enter weightlessness? Now, well, everybody can feel a bit what the launch is like, because the G-forces, you can also get into a roller coaster or the things going around. So 3-4 G. So the launch is not so bad actually. In the beginning, there's a lot of noise and vibration, and it's like in a roller coaster. The feeling you have is like in a roller coaster. If you go there in an amusement park and you want it, otherwise you're not going to wait for an hour in some line. Okay. You know that it's pretty safe, otherwise the thing is not in the amusement park. But then you sit in this chair and they close. You cannot get out anymore. And then you get this strange tension in your stomach from, uh-oh. Same for a spaceflight. I want it for many, many years. I know that it's pretty safe, but I don't know exactly what I'm going to feel. So that's the sensation. And then the acceleration forces, so the G forces, it's 3-4 Gs when you get into the thin layers. In the beginning, it's slow, but then when the air gets thinner, you go faster, 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 then you accelerate. And then after less than 9 minutes, the whole rocket is finished. After less than 9 minutes, all of a sudden the engine stops. And what happens? You start to fall. The earth pulls you back. Doesn't matter how high you are. Gravity just works at 250 kilometers, 1,000 kilometers, wants to pull you back. So the trick is that you start to fall indeed, but then you go so fast forward. The rocket doesn't go straight up. It goes quickly through the dense atmosphere. You saw the nice launches here. And then it starts to bend and it starts to fly towards the horizon. And that's the whole trick. You fly, you put so much speed in the rocket, about 28,000 kilometers per hour, so about 8 kilometers per second. with that speed, you fall to the earth because the earth pulls you. Otherwise, you would disappear straight in the universe. But you fall so fast forward, you constantly fall beyond the horizon. And if you fall, you float. Nothing pushes you, nothing stops you. So if you float, then, well, you can turn around, you can take your colleague and put one finger up, and if you take it away, he stays there, everything floats. And that's in the beginning a strange feeling, because it is falling. So you feel, I'm falling, and you have to relax. Okay, nothing happens. I still fall, but I don't hit anything. And especially after a while, you get used to that, but you feel it as soon as you start to sleep. Because sleeping is normally a mattress. You lie on a mattress, a pillow, and a blanket. Impossible in space. You float away from your mattress. Your pillow floats away. Doesn't matter where you sleep. There's no up and down. You can sleep in the ceiling. You can sleep upright. But what happens, that astronauts fall asleep. You're tired. You do exercise. You think a lot. So you're tired after a while. And then lots of astronauts wake up from, I'm falling, which is true. You are falling, but you never hit the ground. So you have to get used to that very strange sensation that you don't really lie in a bed and safe, but you're constantly falling.
Heb je er al zin in?
But when you get used to it, and then it's nice. Then you feel like a sea lion underwater, and it's very pleasant.
Next question. Shall we go here? And then there? Yeah? Yeah. Microphone is coming. It's coming. I see it coming. There it is.
Did you ever see like a UFO or something else you can explain while you were on ESS?
Well, we are in one now, eh? Flying saucer. So, yes. But don't start straight away on social media. Okay, André, so... But because what does it mean, UFO? It means unidentified flying object. So there was once a moment I was there in the cupola. You saw this beautiful, all these windows, and I looked at the stars, etc. And then all of a sudden I saw a blinking light. And I thought, that's strange. There's no planes here on this altitude. But I see a blinking light. I also told a colleague, I said, a blinking light. So for a while it was a UFO because it was unidentified. I thought, this is strange. You know, I straight away also thought about an alien spaceship because I love science fiction. So for me, there is a lot of life in the universe. So I thought, okay, but if it's an alien spaceship, why does he have a blinking light? Who does he have to warn? You know, an airplane has blinking lights so the others can see it, etc. But I couldn't explain it. But then I realized that it was a satellite. Because satellites, they rotate to be stable. So the solar panels reflect the sunlight now and then. So for, well, maybe a minute, 2 minutes, it was a UFO, but then it turned out to be a satellite. Sorry. I would love to have contact with intelligent alien life. Would be great. But in this case, it was just a satellite.
And I love your outfit, by the way. Maybe if you like, you could stand up and stand here and show your wonderful outfit. Because are you ready to become an astronaut? Look at that. Yeah, thanks, man. We have a question there. And Ali is like running around. Yeah, there was a question. Yeah. Oh, okay.
Hoe ben je erachter gekomen dat je de ruimte zo leuk vond?
How did I find out? Well, my grandmother. My grandfather, she went to a shop and then she saw for 1 guilder, in those days, it was a guilder, 3 science fiction booklets of the series Peri Rodan, originally a German series. It's still going on. Now they have number 3,000, 4,000 or something like that. And it's about all kind of adventures of humanity, of people, of Earth in the universe. And that's how I learned about science fiction. It was in the same period that we had cars on the moon, we had the Thunderbirds on television and all these kind of things. And I thought, oh, this is great science fiction. I went to movies like 2001 Space Odyssey, didn't understand it. I still don't understand it. No. Fantastic movie. I love it. I saw it 25 times. But then I thought, okay, so it became a dream. A boy's dream. I thought, oh, I would love to see the Earth from outer space. But it was only a dream. It was not possible. because it didn't exist in Europe. It didn't exist in Holland. It was something for American test pilots, and something happened behind the Iron Curtain in the Soviet Union, where it was all secret. But then it came closer. The space shuttle came. I saw IMAX movies. I thought, wow, it's not only adventurous, it's also very beautiful. So I was going to learn more about it. Read a lot of books of Giet Titulaar, Piet Smolders, all these books I was reading. And then I also learned how useful it was. So it was the combination of adventure, beauty, and usefulness. I thought, okay, this is it. I want to do that. So that's how I decided, if I get the chance, I want to become an astronaut. I was realistic. I realized that there's a lot of people wanting this. But I thought, if I don't try it, then it will certainly not happen. That goes for everybody. If you have a passion, follow it and see where it ends. And if you're lucky, you make it. So that's how I started.
Wow. If you have a passion, follow it. And you went for adventure, beauty, and usefulness. And you already mentioned teamwork earlier. So yeah, put that on your list and you can go anywhere. There was one question here still. If it still exists, we give you the microphone. And yes, I know there are also people in that area. We will go there next. I see you there already, young man. Yes. Okay, but first here.
Thank you. It's a bit different than the other questions so far. So if I'm hungry, I walk up to just across the street. I have Albert Heijn. I grab a sandwich. I eat it. You can have the little plastic. I can throw it into the underground bin. We pay, I think, €240 a year, and we can dump as much stuff in there as we want. For you up there, the story is, of course, quite different. Every meal is planned, and you cannot just throw waste out of the ship. So the question is, is there any lessons in, let's say, waste management or stuff up there that you took with you, or any insights you have to share on how to be self-sustaining?
Yeah. Of course, we have waste as well in the space station. We have our own waste, urine, you pee. We actually use that again because we make, again, drinking water out of it, potable water. We clean it. Most of your urine is just water. So it's a waste to throw that away or let it burn up in the atmosphere. So we recycle it. Actually, we use the water again to make our oxygen. We split the water in hydrogen and oxygen. The hydrogen was going overboard in the past. It's also a waste because we have to take something else out of the air, another waste, the CO2 that you exhale. Now, normally the plants and the algae on Earth do that for us. We have to take it out with the scrubbers, etc. Now, if you put the CO2, the carbon dioxide, and the hydrogen, and you put them together, you have the so-called Sabatier reaction, you have your water back. So this way we recycle our oxygen atoms. So that's most important recycling we do. There's still methane as a leftover product that goes overboard, but in a future space station that's being developed, we want to use the methane maybe as a fuel to move away from space debris and all this kind of thing. So we want to recycle as much as possible. Why also? Because it's very expensive. To launch 1 liter of water, it's something like €10,000 or something, if you calculate how much it all costs. So recycling is very worthwhile. Now we do the same, for example, with all the stuff that comes up. New computers, food. It comes in big canvas bags. And we have cargo ships that have heat shields, so we can put these canvas bags back in, and they land on Earth, and they can be reused as well. So we want to reuse as much as possible. Now, some things are broken or you cannot use anymore. So that goes in cargo ships without a heat shield, like we had the European automated transfer vehicle or the Japanese module or the Progress. And when it's full, also with the solid waste, the feces, the poop, it's also in containers. Well, we just put it in there and that they break it and then it burns up in the atmosphere. You saw what happens if you go back to the atmosphere. You have 28,000 kilometers per hour. And you have to break that. You put that speed in with a big rocket, but you don't have a rocket to take it out. So we have to find something else to break, and that's what we do in the atmosphere. And that becomes 1,500, 2,000 degrees, so it all burns up. So this is how we get rid of our waste, for example. But like I said, we want to recycle as much as possible, but also because it's very expensive to launch something. It's just it's your money, it's tax money. So
Yeah, and we can learn a lot from space traveling, also to do things better and more circular on Earth, right?
absolutely. No, well, there's actually this technology for that we use with the urine, for example. You can also use in other places. On Earth, we have a lot of water, not everywhere, but okay. But there we can use it, for example, to take the CO2 and we can use the methane on Earth. You can put it into a fuel again. So this is the same process, but then you use a different product of it.
Excellent. There's your next question.
If you could live on a planet, which one would it be?
Ooh.
Well, I think the most beautiful to look at is, of course, Saturn. Nice, but that will be a bit difficult. Mars is the only place, actually, where astronauts can go. But it's still not very pleasant. It's minus 140 in the winter. There is no oxygen. There is no liquid water. There is a lot of radiation. It's a very bad place, actually, but you could survive if you have a spacesuit and you go live underground, etc. I don't know if you were at the presentations earlier, but you can grow food there, for example. So you could, in a sense, live there, but very nasty environment. The other planets, on Venus, it's 500 degrees Celsius. The atmosphere pressure is so much that it's like being underwater for a kilometer or something. And the clouds are of sulfuric acid, zwavelzuur. Not a nice place. So we can forget that to live there. And the others are too far, poisonous. The only place we actually have, and the only planet I want to live on is Earth. We are totally made for this planet. Well, at least with 1G. 1 gravity, 5 kilometers per hour on the ground, and say 25 degrees Celsius. There's a lot of places on our own planet where we don't belong. But we have brains. We can make it nice. We're not birds, we're not fish, but we can build ships. We can go underwater. We can go in the mountains. We can fly. So this is our place. This is our planet, and that's why we have to be so careful with it, because it's the only one.
I hope you're also still happy to live on planet Earth, just like all of us. And you already mentioned the notion of that Earth is a spaceship. And there are no passengers. We're all crew. So we have to also work harmonically for the future of the spaceship. And in fact, I think this spaceship has been docked on this planet Earth also to help us with that a bit. Questions? Woo! Hands. Let's go here, and then after it, a little bit further in the back.
There's a whole cluster here.
Yeah, there's a cluster here.
Where's the microphone?
There's the microphone.
Over here. There's 4 people here.
I can do one here. you.
Thanks. I was wondering which innovation makes you most exciting for the future that we have. Is there a particular advancement or innovation that you think is a big breakthrough?
A big innovation from space. Well, first of all, the fact that we know so much about the Earth, so the satellites, the sensors that we make, I think that's just a very nice one. Spaceflight is, a lot of things in space are old because you want it to work. So if you send up a new computer to space, it has all kind of bugs. Actually, the stuff that we use in space has to be tested a lot. So in that sense, you cannot talk about innovation. But on the other hand, the fact that you build something for space, that is the innovation. It's very difficult to build something for space. You have to deal with vacuum. You have to deal with big temperature differences, plus 150 degrees in the sun, minus 150 in the shade. You have to deal with vibration. You have to deal with acceleration, higher radiation levels because you're above the atmosphere. So, and you cannot just go there for maintenance or repair. So you have to be smart. That's why we have to develop new materials, new technologies, and that knowledge that you can use on Earth for all kind of other applications. So this is the so-called spin-off as well. A lot of things developed for spaceflight find their way back to society. The CT scan, the smoke detectors, airbags, microelectronics that the dentist puts in your mouth for pictures, anti-scratch layers on glasses developed for the helmets of astronauts. Maybe you sleep on a tempur mattress, also a spin-off. The famous heart pump from the Bakey was based on a fuel pump of the space shuttle. So there's a lot of these spin-offs from space. It's not made for that, but it's a very nice thing that comes out of space flight. So new things for a difficult environment, and we can use that knowledge a lot.
Excellent. I want to go to the back. Maybe we have you have some hands there.
Yeah. Do you remember the moment when you thought this must be the Earth overview effect?
Haha. Yeah. That's an interesting one. Because my first mission, you're very intense. You want to do a good job. That's actually what you want. The biggest worry of an astronaut is to make a mistake, a stupid mistake, and it happened. I had colleagues who hit a satellite with a robotic arm, or who toppled a wreck with the cable still attached. Or, people make mistakes. Also, astronauts make mistakes. So this is what you worry about. So everything you do in space takes a lot of time and energy because you're constantly checking the procedures. What you did on the ground in half an hour, in space it takes you an hour or 1.5 hours because you don't want to make any mistakes. So in the beginning, you're mostly working in a lab, trying not to make mistakes. But then you relax a bit and you start to, you cannot work forever. So you go to a window and then in a dark module and then all of a sudden you start to look out the window. And then I realized what I was looking at. And I remember the first time I flew over India and I thought, wow, there's 1 billion people living there. I can just see them all. And they all think that the Earth is endless. But I can see them again in 1.5 hours. I've been around and I can see India in the distance again. And then all of a sudden I realized, I felt that the Earth was more or less shrinking. If I look straight at the Earth, it's beautiful, lots of colors. But then I looked beyond it. So I saw the darkness, saw the space. And then all of a sudden the Earth looks to shrink as if it's a living cell. It felt like a living object with a very thin membrane that could be damaged any moment. So that's when I realized, oh, this is everything. I got claustrophobic, not for myself, but for the planet. Space feels like a very big, very dark, black blanket around it. We're stuck. So that was that was one of the sensations that I had. And another one was, I call it a cosmic feeling. You could call it, somebody who's religious would call it a religious feeling or spiritual. That's the right word probably. I know how it works, but all of a sudden I felt it, that I was part of something bigger. I know it, I know the books, I read it, but if I look around, this is my world, just what I can see and hear. It's very limited actually. And in around the planet, I all of a sudden felt that, wow, I am part of something bigger. I'm part of a solar system. I could see Mars and Venus and the moon, and then we went around, the moon went over. We had a comet during our flight, and all of a sudden I felt that there was all these rotating things, that I was part of a solar system. And you look into the universe, you see all these stars, the Milky Way. So I felt, all of a sudden I felt what I know, that I'm made of star stuff, that I'm part of a very big thing. So that was a very interesting sensation. It's not the overview effect what you meant, that I had with, if you look at the planet, but the spiritual feeling was one of the big things. Yeah.
Yeah, also overview effect, and you also seem to describe this cosmic effect.
Yeah, cosmic feeling.
Cosmic feeling. Yeah, quite wonderful. Wow. Ali, in the back, there were some hands, like all the way in the back. Are you there? Please raise them again so that we can see where to bring the mic. Yes. And I think we should do maybe 2 more questions. I've seen you. Yes.
I can give short answers. Yes and no.
Let's do. Okay, then let's do 3. and after that, because after that it's not the end of the evening, we will move again to the other side, stretch the legs, and there we can have some bites, drinks, and maybe ask a few more questions to André and dance a bit. So it's not the end of it, but then we
Do I have to answer and dance at the same time?
If I like to see you do that, I think you are such a talented man. It should be easy for you.
In
But
weightlessness, I can dance.
all right. Okay, please ask
Hi.
your question.
Thank you for the movie. I have a short question. What is your opinion about the commercial space travel? That's going
Yeah,
on right now?
that's a natural thing, I would say, because same thing happens with shipping, with aviation. It all starts first with a few individuals, experimental. Things go wrong, then often becomes military. They have the money. Then it becomes cargo, and then it's become so common that you get passenger transport, etc. And also in space flights, the same thing happened. It is already commercial. If you look at the weather forecast, the Meteorological Institute, they need the data. Then you need to have a deal with Meteosat. You need some satellite data. Meteosat builds a new satellite. They go on the rocket market. Who has the nicest and cheapest and best rocket for me? So it's already a commercial project already. And now it's happening also with humans. So in the past, it was NASA or ESA that decided, okay, we're going to build this, and they had all control. Nowadays, they say to SpaceX, to Boeing, okay, here's a lot of money, you build it, we just check if it's safe enough, and then you do it. So because companies are competitive, so it can be more efficient. So it saves, it saves money in that sense for the taxpayers, etc. It can go good, like SpaceX, they do a fantastic job. It can go wrong, like Boeing. They send up a ship and then they cannot have the crew back, etc., because there were mistakes. So this is the entrepreneurship that's what's happening. So it's a good process, but very important. You have to have regulation. It should not be some kind of Wild West situation where everybody makes his own rules and just. Well, the problem is with the satellites, for example. We have now 6,000 useful satellites. Everybody uses it. We use it for navigation, for the weather forecast, for communication, Earth observation. It's our money. It's our satellites. All very useful spaceflight. But now we get also, we have companies like Blue Origin from Jeff Bezos, Amazon. They want to have thousands and thousands of satellites. Starlink from SpaceX, they want to have 40,000 satellites to make money. So Elon Musk can go to Mars. That's in the back of his mind. But the Chinese are also going to send up a lot of satellites. OneWeb, another company. So not far from now, we will have 100,000 satellites. So it's nice, it's commercial, but we have to be very careful because these things are going to hit each other. We already had accidents. And so we have to regulate the commercial activities in space. It cannot be that they decide their own rules. So what is happening in the United States with Elon Musk getting into government actions without being able to be controlled because it's not part of a ministry, this is very worrying. Because you might have a Wild West situation with us as taxpayers and users as the victims. So let's see what happens there. And I hope everybody's wise enough to make sure that what we do in space is regulated. That companies do the job is great because they're probably more efficient and can do it cheaper, etc. But we have to keep it under control.
And to the benefit of all of humanity rather than just some private dreams of a few billionaires. Because the space tourism is also coming. I opened the evening with the observation that right now, at this moment, there are more people flying in airplanes than used to live on the surface of Earth in the Stone Age. So yes, that's thousands of years ago. But still, 2 centuries ago, it was very rare to fly in an airplane. And now it's quite normal. But you are still the only Dutch person ever to go into space until now. Yeah, what if that becomes like the next summer holiday?
Yeah, well, this is a development that we saw in shipping. We saw it in aviation. And there we have the same discussion. So far, what is done in space is useful. Yeah. I'm a professional astronaut. I just work for the taxpayer to do useful things in space. And even the tourists that are going up now would pay their own ticket. They most of them, I think all of them,
Mhm.
had their own scientific projects with them.
Yeah.
Maybe to feel good for themselves also, but they had contacts with hospitals, with universities, at their own research a bit. So it's a bit of a gray area now, but you will soon get people who just go for fun. And then you get the same discussion as we have at aviation.
Yeah.
Aviation can be very useful. I think it's also very important for people to see other cultures and travel and learn the world, so that you don't start to think that your own country is the best and the rest is minor or something.
Mhm.
So that has positive effect as well. But you have to weigh it against the negative things of it. And the same goes for spaceflight. Now, if you have a rocket launch is polluting. Yeah, we get cleaner rockets all the time. We stop with hydrogen rockets in Russia, etc. So and we get reusable rockets like SpaceX. That works very well.
Mhm.
So you have to make the balance from what the use is, and if it becomes an attraction for a few people, then it's doubtful. Same with aviation.
Exactly.
It's good that people travel, but the other side is that it's polluting. Although the engines are getting cleaner and more quiet, etc. So it's always a trade-off.
Clear. I had this young lady there already preparing a question. Are you still on top of your question? Yeah. There's the microphone.
Wat is je grootste blunder die je ooit hebt gemaakt in de ruimte?
Oh, dat is een goeie. Ja.
The banana.
That's a good question because, like I said, astronauts make mistakes. Astronauts make mistakes. I had a colleague who had a software company in the past, so he knew everything. I knew everything about computers and software, and he thought to do something on his own. Well, that went wrong with that computer. So people make mistakes, and so did I. And in the beginning, you might make a mistake because you're a bit space sick and it's all new. Then there is a period in space that you're perfect, you know everything. But then, like with every job, you become sloppy, slordig. That you start to think that you know it already, that you don't check it anymore, because I did it so many times. And that happened to me. I had to do an experiment and I had to breathe some gases in. So I had this mouthpiece and breathing gases. And I did this experiment before. And in the procedures, it said, okay, make sure that the hose is free. And I didn't pay attention. So what happened? The device through which I had to breathe, there was a little handle. And that moved with the inside system, because maybe sometimes you have to do it by hand, manual. And I saw it happen. So this gas hose was going through, and then I saw this handle move. And I thought, oh, this is wrong. And indeed, there was too much tension and the connector broke off. And I thought, oh man, stupid, because this is an experiment of a scientist I knew already for 30 years. So his experiment I ruined. So I quickly closed the gas bottles, etc. And so I called the ground and I said, well, you probably saw it. They didn't see it yet, because normally there's cameras on it all the time, but I didn't notice it yet. And I said, okay, I broke off the connector. Stupid. Towards the end of my flight, do you have a spare part? Because we have a lot of spare stuff. And especially that piece, we didn't have a spare part. So I thought, oh man, now I make a blunder, a big mistake. And then, of course, you start to find a solution. And I knew from another experiment, there was a similar connector. So I cannibalized this other experiment. And so I could fix it in the end. So in the end, we could still do it. But that was a mistake because I became sloppy in the end. It's always very dangerous. If you do something a lot, you become too much routine, and then you think you know it. But so the same, because of that, there was another experiment that I already did 20 times, and I knew the procedures by heart. Very simple. And then I thought, okay, I know it. I do it without procedures. It's faster. And then I thought, no, maybe not. So I took the procedures from the screen, and I looked, and I thought, this is strange. This is different. So I called the ground. Did you switch step 4 and 5? Yes, we did switch it. But they didn't tell me. They didn't have to, because I was supposed to read the procedures. But if I would have done the procedures correctly according to the first 20 times, I would have made a mistake. So even if you know it by heart, things might have changed. So you can still make a mistake. That's why it also takes so long lots more time in space to do it correctly all the time.
Yeah, it is rewarding in a way to hear that even you make a blunder
Absolutely.
sometimes, just like everyone. But also you can learn from it and
Oh yes,
start again.
this is the best way to learn, to make a mistake.
Exactly. I think people have been seated here for a long time. It's time to switch to the other room and round this session, end this session. I want to thank you, André, for your service as an astronaut, for your wonderful movie, but most of all for being such a wonderful, good human being. Thank you so much, and big applause for André
Thank you.
Kuipers.
Thank you.
And as I already said, we all moved to the other side. I will try to bring André there, and we can have a little drink and maybe a little chat and a little meet and greet. And there will be bites and snacks and dancing. There's holiday starting. You're welcome here to visit again. Please do. See you soon. And on the 14th of February, there will be our next Friday which will be about the future of love. Thank you so much, and see you then.